Hi everyone, this will be a refresher video on solving quadratics using our second method, which is the quadratic formula. So our first method that we just finished was solving by square roots, and now we're going to move into method number 2, quadratic formula. We have this first question that says, we've been solving quadratic equations using square roots. What do they all have in common? So let's recall our falling object model. So as of yesterday and the day before, we had our falling objects, which was always h of x equals, or I can use h of t. H of t equals negative 16t squared plus h naught. We're looking for a connection, though, to our general quadratic form, which is actually down here. So if I look, I have the squared term. I do not have a term, the middle term, bx term, but I do have a constant at the end. So we could actually say that this is the same as f of x equals negative 16t squared plus c. So that constant at the end, our initial height, is that last term here. So they do have this a squared, in this case for the falling objects it was negative 16. We have a squared term and we have the constant term, but all of those models are missing the same thing. They were missing the bx term in our original parent quadratic, so to speak, ax squared plus bx plus c. So this was missing. See, we have our squared term, negative 16t squared, and we have that number at the end with no variable, but none of these in our model here, see here and here, neither of them have like plus 8t or minus 6t. Because they were missing that middle term, we could always solve with square roots. We could solve using square roots. So now the question comes up, how do we solve quadratics that do have a b term, that do have this middle term? We must use the quadratic formula. And I am hoping this is a prior knowledge lesson for us, that we recall at least seeing this last year for 9th grade and hopefully using it a little bit. Important note, the equation must be equal to 0 before identifying A, B, and C and using quadratic formula. We'll use QF for short. So here in size 70 font, I have the quadratic formula. We do need to have this memorized. So write it over and over. We need to have it firmly in our brains. We read it out loud. X equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So if you practice saying it out loud, it also helps you remember it. So I recommend practicing. I'll leave that in the box. If you want to highlight that, it'll stand out in your workbooks. The reason we're refreshing our skills on this is because we are about to start looking at objects that have velocity. So here we have a time-lapsed photo of a basketball player shooting a basketball. Here, from where he releases it, he has to put velocity on that ball for it to create this shape. And I'm hoping that we recognize the shape, the shape that the path of this ball is making. Notice, if I trace it, it's a parabola. It's quadratic in nature. But to be able to solve these real-world questions, we have to have our quadratic formula skills down and be comfortable with it. So we are going to start practicing right now. It says, solve the quadratic equation using the quadratic formula. So on my screen here, I can't see my original quadratic formula. So off to the side, I'm going to write it for myself. And I know you can see it on your paper, but pretend like this was a classwork assignment that I did not give you the equation for. And write it down. The more you write it down, the more you will remember it. So x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Just put that in a little box for yourself off to the side for reference. I also want to remember that we just wrote an important little note that said the equation must be equal to 0 before we can identify a, b, and c and keep going. So let's check. In number 1, is this set equal to 0? Yes, so I'm good to go. Let's identify a, b, and c. To be able to identify a, b, and c, when I see this equation in my brain, I need to think ax squared plus bx plus c equals 0. Where a, b, and c are the coefficients. Remember, coefficient means the constant, the number out front. So ax squared, I need the coefficient of x squared. What number is here? You'd be like, Ms. J, I don't see a number there. And then I hope the next thought is, oh yeah, I remember that there's an invisible 1 right there. That's always there, we just don't write it. So a is 1. bx, so now I'm looking for the coefficient next to x, the constant number next to x. When I look, that's negative 2. And now c, I'm looking for my constant term that has no variable, and that's a negative 15. Making sure we get our signs right is important. If I dropped a negative here by accident, the rest of my work, no bueno. It's going to come out wrong. So let's use this model. We're going to follow it exactly. X equals negative b. So that's going to be negative, and I'm plugging in negative 2, plus or minus the square root of b squared. B is negative 2, so negative 2 squared minus 4. So far we've done negative b plus or minus, and now I'm working on underneath the radical b squared minus 4ac. So minus 4 times 1, because a is 1, and then I'm going to multiply by c, which is negative 15. That square root ends after you finish writing minus 4ac. This is all divided by 2a. So in this case, 2 times 1. We're going to draw a line down our equal sign, and that's going to be nice because it's going to keep all of our work super neat. All of our equal signs are going to go on this line. Negative negative 2 is a positive 2, plus or minus. Let's see. Negative 2 squared is 4, and then 4 times 15. Now notice, I didn't say anything about signs, and the reason I didn't say the signs is because I actually looked at the signs first in my brain. So in my brain I said negative times a positive, negative, times a negative is a positive. So I decided on my sign first, and then now I can just look at the numbers. 4 times 15. If you don't have your calculator out yet and you feel more comfortable using it, that would be fantastic for you to press pause real quick and go ahead and take it out. And when I do 4 times 15, I get 60. This is all divided by 2, because 2 times 1 is 2. Notice how much smaller it got, even just from the first step to the second step. This becomes 2 plus or minus 4 plus 60 is 64. And notice I'm keeping fraction, fraction, fraction. All these fractions are staying together. I know, and remember, that the square root of 64 is 8. So this is 2 plus or minus 8, all divided by 2. And now that I'm here, I can break it up. We're going to have one answer that comes from the positive and one answer that comes from the minus. So when we say plus or minus, that really is actually representing two different answers. It doesn't matter which one we do first. I'll just choose to do plus. So I'll do 2 plus 8 divided by 2. And then my second setup will be 2 minus 8 divided by 2. So I do 2 plus 8 and I get 10. Divided by 2 is 5. You finish this one and we'll see if we match answers. 2 minus 8 is negative 6. Divided by 2 is negative 3. And we're done. Those are our answers. 5 and negative 3. This process repeats. So this entire exercise, we're going to follow the exact same steps with the goal of becoming so comfortable we have no problems with this skill whatsoever. And that only comes from practice, practice, practice. So taking a look at number 2, it looks a little crazy at first. And if I look for my equal sign, it's actually right here in the middle. So when I see this, I want to think to myself, like I see a squared term, I see the bx term, and I see this constant, but the problem is, I need this set equal to what before I can go forward? I look at my notes that I just took. It has to be set equal to 0. So how are we going to do that? Well, we want to avoid having a negative x squared term, just because it's nice if we can avoid that for the quadratic formula. If I see a positive 3x squared here and x squared here, I know that if I subtract x squared, when I finish doing that, this will stay positive. So that means I'm going to choose to move everything that's on this right side over to the left. So I subtracted x squared. I can also at the same time add 6x if you're comfortable doing that. If you're not comfortable doing that at the same step, don't do it at the same time. So I will do it as a separate step. So that gets me 2x squared plus 4 equals negative 6x. Now I will add 6x to both sides. I get 2x squared plus 6x plus 4. Why did I have to write it that way? Why couldn't I do 4 plus 6x is 10? Well, if I remember my knowledge about like terms, my follow-up question would be, are 4 and 6x like terms? Answer is no. But then you could be like, but Ms. J, there's x and x squared. I can add those together, right? So my question is 2x squared and 6x like terms? So remember, like terms, same variable, raised to the same exponent. So let's see. These both have x, which is fantastic, but do they have the same exponent? Well, this is x squared. This is not x squared. This is x to the first. So no, these are not like terms. Like terms have to have the same variable and the same exponent. So my result is 2x squared plus 6x plus 4 equal to 0. Now that this is equal to 0, I can keep going. I can identify A, B, and C. I'm actually going to shift this over here, and I'll be doing my quadratic formula work over here. So on your own, go ahead and identify A, B, and C, and we'll see if we match. Press pause. I have A equals to 2, B is 6, and C is 4. New page. I don't see the quadratic formula anywhere here, so off to the side I will make a note of it for myself. Let's see if you can write it without looking at the previous page. Can you write it from your memory? Give it a try. I'm about to say it out loud in a second. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So now I have that as reference for this whole page. I can use it. So I'm going to set up x equals, and the setup step is the most important. If I write this first step correctly, I'm much more likely to get this right. So we'll be very careful, we'll take our time. Negative b, so that'll be negative 6 plus or minus the square root b squared. What's b? b is 6, so 6 squared minus 4a c, all divided by 2a. So as I said that out loud to myself, which is something you could kind of say in your head while you're working, when I said negative b, I looked and saw that b was 6, so I wrote negative 6. Plus or minus square root b squared. b is 6, so this became 6 squared. Minus 4, a is 2, c is 4. Minus 4ac, all divided by 2a, where a is 2. So if you have that phrase, the words in your head, it'll help you write this. So don't just write this down, but practice actually saying it out loud. We're ready to start simplifying this, so negative 6 will stay, plus or minus the square root. 6 squared. What is 6 squared? 6 squared is 36. This is a negative times all these positives, means that I have a minus sign here. Remember to decide your sign first. 4 times 2 is 8. What's 8 times 4? 8 times 4? 32. All divided by 2 times 2 is 4. Equals negative 6 plus or minus. What is 36 minus 32? 36 minus 32 is 4. All divided by 4. We have a perfect square there. The square root of 4 is 2. So I can rewrite this as negative 6 plus or minus 2, all divided by 2. Go ahead and find your two answers. Break this up, plus and minus. That is not the bell for the video. It's just in the background, sorry. So let's see, we get x equals negative 6 plus 2 divided by 2, and x equals negative 6 minus 2 divided by 2. Negative 6 plus 2 is negative 4, divided by 2, and I get negative 2. Negative 6 minus 2, negative 8, divided by 2, negative 4. Oops, typo, sorry. When I was copying this, I'm not sure if anybody caught this before me just now. See if you can spot my error as I backtrack here. What did I do wrong? From here to here. And this is totally something that you could do too by accident, so I'm happy I made the mistake. So as I came to the end, I started going a little faster, and by accident, I have a copy error. Instead of writing a 4, check out what I wrote by accident. I wrote a 2, which is going to mess up my final answers. Now, if that happened to you, I would be able to see your work because you showed it so well, and you would earn almost full credit because that was just a small little mistake. So I backtracked. All my 2's in the denominators became 4's. Now negative 4 divided by 4 is negative 1. Negative 8 divided by 4 is negative 2. And now we are all done. So that ends our flipped notes for tonight, helping us to remember everything we know about quadratic formula. If you would like to keep going, you'll be starting to work on the classwork that is planned for our next class. And a heads up, if you do keep going, there are a couple that do result in a decimal answer. That does not mean you did anything wrong. Decimals are good numbers. So don't always expect them to come out as whole numbers. And that is getting us ready for the real world, where very little in the real world comes out to be whole numbers. So if you start working on these on your own, you get decimals, no worries, and good job. Have a great night, everybody.